Hello everyone, in this video tutorial, we will see how we can train YOLO-NAS model on custom dataset, and we will be training YOLO-NAS model on personal protective equipment dataset, and here are the output demo results which you are seeing over here. So let's get started and explore how we can train YOLO-NAS model on personal protective equipment dataset or any custom. So here is our Google Colab notebook. But before running the script, please make sure that you have selected the runtime as GPU. So you just need to click on runtime and click on change runtime. And here you just need to make sure that your hardware accelerator is set to GPU and GPU type is T4. Okay, so we have set our runtime as GPU. So in the first step, I will install the packages. So I will just click on run this cell. So this might take few seconds for the packages to get installed. So we are installing SuperGradients, IMUtils, RoboFlow, PyTube package. So now you can see that we have installed the packages, SuperGradient, IMUtils, RoboFlow, PyTube. So now in the next step, before going to import the required libraries, I will restart the runtime. So I will just click over here and click on restart runtime and just click on yes over here. So after restarting the runtime, then I will import all the required libraries which are listed over here. So I will just click on run and import all these required libraries. If you don't restart the runtime and try to import the libraries, you will get error. So it's necessary that you restart the runtime and then import all the required libraries. So in the next step, what we'll do, we will be setting the checkpoint directory and experiment name and instantiating the trainer. So here, basically, we are instantiating our trainer and we are setting the checkpoint directory and experiment name. So inside this checkpoint directory, we will be creating this we will be creating a folder by this name. So first of all, we will create a directory into the project file section over here by the name checkpoints2. And inside that directory, main directory, we will have the subfolder by the name PPE YOLO-NAS run 2. So inside this folder, we will have our best model fields, log files, and other required files saved over there. Okay, so this checkpoints2 will be the name of our main directory. And inside that main directory, we will have a subfolder by the name PPE YOLO-NAS run 2. And inside this folder, we will have our best weights, log files saved. So just run this over here. And okay, so now I will export the dataset from RoboFlow into this Google Colab notebook. So in this tutorial, as we are detecting personal protective equipment, so I will be using a personal protective equipment dataset available on RoboFlow. So here we have the dataset. You can see over here in the RoboFlow, we have this dataset. I have already created an account on RoboFlow. So if you haven't created your account on RoboFlow, just sign up and create your account on RoboFlow. Okay. So you can just sign up over here and create your account on RoboFlow. It's free, and you can go to RoboFlow universe and export the dataset from RoboFlow directly into the Google Colab notebook. So this is our dataset. The dataset consists of 3,235 images. Okay. So just refresh it. If you just ever face this error, I recommend you to refresh your browser only. So this will definitely solve your error. Okay. So just refreshing my browser. Okay, so just wait a minute until my browser gets refreshed. Now you can see that we have refreshed our browser, and here you can see over here, we have the dataset and here are the sample images. So now here you can see that we have 2,300 images out of 3,235. We have 2,300 images in the training, 647 images in the validation, and 324 images in the test set. So when we do the while training any YOLO model, so usually what we consider 70% of the images in the training data, 20% of the images in the validation set, and 10% of the images in the test set. So here we have the balanced data. We have considered 70% of the images in the training, validation data set contain 20% of the images, and testing data set contain 10% of the images. Okay, so that's look great. So you can just rebalance the data set. You can consider 80% of the images for the training, 10% of the images for the validation, and 10% of the images for the test set as well. But in normal practice, we consider 70% of the images in the training, 20% images in the validation, and 10% images in the testing set. Okay, if I go to the health check further, so now you can see that 3 of my classes are not balanced, while first 4 classes are my balanced. Okay, so here you can see 0, 8, 9, 3, 4, 6, 11. We don't have the label name, like this is the helmet, this is the jacket, these are the gloves, these are the protective boots. Okay, these are the protective eyewear. So when I will be training the dataset, I will just change those labels from 0 to protective helmet, 8 to jacket, 9 to gloves, and 3 to eyewears, and 4 to mask. So I will just update this data set. So from overall, we can see that our 4 classes are balanced. We can see over here, while 3 of our classes are unbalanced. And we have a data set consist of 3,235 images, 3,235 images we have in our data set, and total number of annotations we have 14,341. And the image ratio is 416 cross 416. Okay, so that's look fine. And then we go to the train YOLO-NAS custom dataset, again code towards the code. So if you want to export this dataset from RoboFlow into your Google Colab notebook, you just need to go overview, click on download this dataset, and just select the format. So you can select the YOLO-V5 PyTorch format, and then go to continue, and you can just copy this from here. Okay, so just copy this from here, and okay, so just copy this all this from here and there. Or if you are just using PyCharm or Visual Studio, you can just copy this terminal command. But if you are using notebook like Colab notebook or Jupyter notebook, you will use this code from here. So just copy this code from here and paste this code over here, and you will be able to export the dataset from RoboFlow into your Google Colab notebook. Okay, so I'm just downloading the dataset from RoboFlow into the Google Colab notebook. So it is a quick download process. You can see over here, it's almost 100% done. Okay, so just going a step ahead. So now after we have downloaded the dataset, so now in the next step number 5, we will load our dataset parameters into a dictionary. Okay, so you can see over here, if I just refresh it now, we have the dataset over here. We have the train, test, and validation folder. In each of the folder, we have the images labels. You can see in the training folder, we have the images labels. In the test folder, we have the images label. Okay, and in the data.yml file, we have the labels 0, 1, 11, 3, 4, 6, 8, 9. So I don't want it. I want the label like it's the protective helmet jacket or other thing. So I will just delete file from here. Delete this file from here, and I will just upload a manual file from my directory, local directory, where I have just done the label. So it's in the, okay, so if I just go to over here, okay, so I will just upload it from here. Here I will have the data.yml. So I will just upload this updated data.yml file. So if I just show you, so now you can see that we have the same 7 different classes, but instead of 0, we have the protective helmet. Instead of 1, we have the shield. We have the, now we have names for each of the class. Instead of 0, 1, 2, we have the name for each of the class. So this is what I update, or I updated the data.yml file. Okay, so if we just go ahead further, okay, so here you can see that we have the dataset parameters over here. You can see all those dataset parameters here. I have just defined that data directory. So I will just click over here, copy path from here, and just paste this path over here. Okay, and inside this directory, you can see that we have the train folder. Inside the train folder, we have the images label. So here we have defined the train image directory, train labels directory. Inside the validation folder, you can see that we have the images labels. So we have defined the validation images valid labels, and inside the test folder we have the images labels. So I've just set the test image directory, test labels directory, and in the data.yml you just need to copy all these labels from here in the same sequence it is listed over here. Like first one is protective helmet over here, just need to copy protective helmet and just write the class name over here. And the second is shield, you just need to copy it and write the second order. So you just need to follow the same order which you have in the data.yml file. So just copy all the label names from here and just paste it over here. Plus don't mix up the order. It should be in the same order that it is given over here. Okay. So the last one is protective boots, which you can see that last label name is protective boots, and we have the last label name as protective boots. Okay. So in the next step, we will pass the values from the dataset parameters, which we have over here, into the dataset parameter argument as shown below. So here we have the dataset parameter argument. We will just pass the values from here into this dataset parameter argument. Okay. So now I will just inspect the dataset defined earlier. So just inspecting the overall dataset defined earlier. Okay. So now I will just plot a batch of training data. Okay. So to see how my dataset look like, and we can see the bounding box around the detective objects here as well. So now you can see that I have just plotted a batch of the training data with their augmentation. So see how it looks like. So you can see that we have bounding box around each of the detected object like jacket, mask, helmet. So we have the bounding boxes you can see over here, but we don't have the label. Only we are just drawing up bounding boxes around each of the detected object. Okay, so the results look fine. Okay, so now in the next step, we are instantiating our model. Okay, so now YOLO-NAS comes with three different models: YOLO-NAS small, YOLO-NAS medium, YOLO-NAS large. In this tutorial, I am using YOLO-NAS small model. So YOLO-NAS small model is very fast, but it is less accurate than YOLO-NAS medium and large model. While YOLO-NAS large model is the most accurate among YOLO-NAS models, but it is less fast. So I am just using YOLO-NAS small model because it is fast, but it has a drawback that it is less accurate. Okay, so I'm using YOLO-NAS small model. I've listed over here, and in the num classes, I'm just passing the name. I'm just calculating the length of the classes in my data set. So I have 7 classes. So this will give me output as 7. So so you can see that here I'm just passing the dataset parameter. Okay, so you can see that I'm just using this dataset parameter. You can see here I have the dataset parameter inside it. I have classes. So you can see that 1, 2, 3, 4, 5, 6, 7. So I just have 7 different classes. So when we find the length of this dataset parameter classes length, so it will give us 7 because we have 7 different classes and we are using Coco dataset pre-trained weights. And this tutorial, we are using YOLO-NAS small model. Okay, YOLO-NAS has medium and large model, but for this tutorial, we are only focusing on YOLO-NAS small model. So we have done this. We have done the inspection of, okay, so we have done all this. So now we will define metrics and training parameters in the next step. So just remember, there are few mandatory arguments that we must define for training parameters. Okay, so when you define the metrics and train parameters, so there are few mandatory arguments that you must need to define for the training parameters, which include in the training parameters, you must define the maximum number of epochs, your loss function, your optimizer, whether you are using atom optimizer or RMS pop, your train metrics list, valid metrics list, and metrics to watch. Either it is mean average precision with IRU 0.5 or IRU varies from 0.5 to 0.95. So in the optimizer, we have Adam, STD, line, RMS prop. So you can choose any of the optimizer if you as per your requirements. Okay. So now as I told you, there are few mandatory requirements that you must pass in the training parameters dictionary, but you can also add or adjust other train arguments as well. So now you can see over here, I have defined optimizer as Adam because it is a mandatory argument. You can see that optimizer is a mandatory argument when you define for the training parameters. Okay. And I have also defined the loss over here. You can see that I'm using PP YOLO-E loss. Thus, LR mode is being considered as cosine. Thus, I have also defined the maximum number of epochs as 10. Like I am training or fine-tuning my YOLO-NAS small model on PP dataset for 10 number of epochs. So I'm just fine-tuning the YOLO-NAS model on PP personal protective equipment dataset for 10 number of epochs. Okay. So I have not run this cell, so I've just run this cell as well. And I will also run this cell again as well, the training parameter cell. So now you can see that here I have also defined the metrics to watch, which is mean average precision with IOU of 0.5. So if I just go over here, it has listed over here that metric to watch, you must define the mandatory arguments. In the mandatory argument, there should be, you must define metric to watch, and our metric to watch is mean average precision with IOU of 0.5. So this is a must right argument which I have listed over here. So now I will download the demo videos from, I have placed some demo videos to test my fine tune or train YOLO-NAS model. So I'm just downloading the demo videos from Drive directly into this Google Colab notebook. So instead of uploading each of the videos separately over here, I have just placed all those videos into the Drive. So I'm just directly downloading those videos from the Drive into this Google Colab notebook. Okay, because if I upload these videos over here, this will take time. So I'm just downloading. You can see here demo.mp4 is here. Okay. So now after we have done this, after we have downloaded some demo videos from the Drive into this Google Colab notebook, the reason I'm downloading this demo videos because I want to, after training or fine tuning the YOLO-NAS small model on personal protective equipment dataset, I want to test how much my model detections are perfect or how much my model detections are good. I will be testing on this demo videos. Okay. So now I will just start the training of my YOLO-NAS small model on the personal protective equipment dataset. So the training will take around 1 hour. So as the training start, I will just pause the video, and when the training complete, I will be back, and then we will discuss the training results, and then we will test our trained YOLO-NAS model on images as well as on videos. So if I just refresh it, so now you can see that a checkpoints to folder has been created, which I have already told you. This is the main directory. Inside the main directory, we have the subfolder PPE YOLO-NAS run 2. And inside this folder, we will have the best weights and the last model weights and average weights over here as well. And batch size is 16 and total batch size is 16. Iterations are 141, and we have 1 GPU because we are using Google Colab free GPU. So we have the 1 GPU over here, and our training data set consists of 2,264 images, which I have already shown you over here. Like I told you that we have around 2,300, which is 2,264 images in our training data. So the training has been started. So when the training completes, I will be back, and then we will discuss the training results, and when we will go ahead as well. So I have trained the YOLO-NAS model on personal protective equipment dataset. So after training the YOLO-NAS model on 10 epochs, and here are our training results. So you can see that the mean average precision obtained with considering an IOU of 0.5 is 77.78%. You can see over here 0.778. So the mean average precision obtained considering an IOU of 0.5 is 77.78%. And here are our training loss. You can see over here, because we have defined the loss as PP YOLO-E loss. So these are our loss. You can see over here. And here are our model performances on the validation set. So we have not used the validation data for the training. So it's always better to have a look and see how our model is performing on the validation data set. So we can see over here that the precision obtained considering an IOU of 0.5 is 12.69%, while the recall score obtained considering an IOU of 0.5 is 88.38%, while the F1 score or F1 value obtained considering an IOU of 0.5 is 21.87%, while the mean average precision on the validation set obtained considering an IOU of 0.5 or 50% is 73.82%, which is listed over here, 0.7382, which is 73.82%. So now after training, you can see over here, in the training, we have just used YOLO-NAS small model. So YOLO-NAS comes with 3 different models: YOLO-NAS large, medium, and small. I have already told you YOLO-NAS model is less accurate, but it is fastest as compared to other YOLO-NAS model. While YOLO-NAS large is the most accurate, but it is less fast as compared to other YOLO-NAS models. So here I'm just passing the pre-trained model name over here, and you can see that after we train the model, we can see that in this folder, checkpoints 2, which we have already created by our own self. And here we have the PPE YOLO-NAS run 2. You can see that we have the best weights file, and the latest means the model weights on the last epoch. And we have the best weights mean the weights on which the model or the epoch on which the model give us the best results in terms of mean average precision. So here we have the best weights file, and these are the model average weights file. Okay, so we will always use best weights file to evaluate our model on images, live webcam feed, or on the some sample videos. So I will use the best weights file. So I will just copy path from here and just add this path over here. We can just remove this content part because our current directory is being set as this project file section already. Okay, and in the dataset parameters, I will have just pass the classes, and I'm just finding the length of my classes. So you can see that if I just go above over here, if I just go above a bit further, so now you can see that in the dataset dash parameters, I have defined the classes. So my basically personal protective equipment dataset consists of 7 different classes, which you can see over here. So I have just finding the length of this list I have created. So the length will be 7 because I have listed 7 different classes. Okay, so I'll just go further down and back to where I was explaining. Okay, so now you can see that I'm just finding the length of my dataset classes. So it will be 7. And here in the checkpoints path, I have just passed my model best weights. And here I have fine-tuned or trained the YOLO-NAS model on the YOLO-NAS small model on the personal protective equipment dataset. So as I trained or fine-tuned the YOLO-NAS model, small model on the personal protective equipment dataset. So as I've used YOLO-NAS small model, so I've just listed over here YOLO-NAS small model. Okay, so just run this cell. Okay, so now we will evaluate our best trained model weights on the test dataset images. So now here we will be evaluating our best model trained weights on the test dataset images. So I will just run this cell. Okay, so this might take 2 seconds before we get the results. Okay. So now you can see over here the mean average precision considering an IOU of 0.5 is obtained as 80.20%. Currently it is in the form of tensor, but if you just write int, then this tensor will be converted into integer. So, but we are just concerned with this value. So the mean average precision obtained on the test dataset image is 80.20%, while the F1 score considering an IOU of 0.5 is obtained at 10.95%, while the recall score is obtained as 98.28%. So now we will be using our best model weights, which you can see over here in the best test model. I have just passed my best model weights. You can see over here. So I will be using my best model weights to test my model on some sample images and videos. So I have just passed a random image from my data set in front of the validation images. I've just passed a random image. By you can just go over here and click on the copy path from here. You can just click on copy path from here and just select this. Okay, and just put Control V over here. Okay, and just test your model, fine-tune model or train model or YOLO-NAS model on some images. So now you can see that the person is wearing a glove. So model has correctly identified that the person is wearing a glove. So the model results are very satisfactory. So now we will be testing our model on some videos. So I will just, in the input video path, I will just pass the input video over here. You can see that I have already downloaded the videos from the drive directly into the Google Colab notebook. So now over here, you can see that I have the video. So I can just click over here, copy path, and just paste this path over here. Okay, and in the output video path, so after doing the detection on this sample video, my output video will be saved by the name detections.mp4. So in output video path, we write the name of the video or we write the name with which we want to save our output video. So in the output video path, we write the name with which we want to save our output video. So we just want to save our output video by the name detections.mp4. So here I have written detections.mp4. So my output video will be saved by the name detections.mp4. Okay. So Now I'm just, so as I've already done the processing on this video, so I will just not run it again because I've already done it. But if you want, I can just do it once again. So just check it out. So I'm just using my best model weights, and I'm just uh, doing detections on this video, input video. Okay, and my output will be saved by the name uh, over here, which you can see over here, out detections.mp4. Okay, so let's see, it's currently processing. So it might take few seconds more. So okay, so we have done prediction on this sample input video. So let's display this output video over here and see if we are able to detect the personal protective equipment or not. Okay, so this might take few more seconds, so please wait with me until we have the video output to be displayed over here. Okay, after this we will test on some other video as well, so don't worry and keep watching. Okay, so this might take few seconds, so let's wait and see. Okay, this usually takes few seconds to display the output video over here, so let's wait and see. Although the size of the video is very small, but to display any output video into Google Colab notebook, input video or output video into the Google Colab notebook, this is a bit time-taking process. So here we have the output video. If I just play it over here, due to small screen size, it will be difficult to see the output correctly. Let me just download this video and just navigate my screen towards it. So let me just navigate my screen and show you the output. So now you can see over here, okay, so let me just play it again. So now you can see over here, the model is able to detect a protective helmet over here, a gear and jacket as well. So the model detection results are very perfect. That's amazing. We are able to detect the protective helmet, you can see, as well as the jacket over here as well. Okay, so let's go back towards the code again and test on other demo video too. So now here I've just passed the video path of the demo new video too. You can just go over here, copy path and add this path over here. Okay, so now we will be doing detections on this input video, which is demo new to mp4. So this let's get started. So this might take few seconds until so the prediction on the video is about done. So okay, so now let's display the output video into our Google Colab notebook. So this might take few seconds for the output video to be displayed over here. So as we have the output video ready over here, I will just download this output video and I will show you how our detection results look like. So this might take few more seconds. So let's wait and see until we have the output video ready to be displayed over here. Okay. So I'm just waiting for it to complete and then I will show you the output video over here. Okay, so now you can see that our video is processed. Let me just download the output video because due to small screen size, we might not see the output very clearly. And let me just navigate my screen towards the output. So now you can see over here, this person is only wearing a jacket. So we have only, so now you can see that both of the persons are wearing the protective helmet. So we have detected correctly that both persons are wearing the protective helmet, while only this person is wearing the jacket. So we have correctly detected that this person is only wearing the protective jacket, while this person is not wearing the protective jacket. So that's all from this video tutorial. In this video tutorial, we have seen that how we can train YOLO-NAS model on custom data set. I hope you have learned something from this video tutorial. See you all in the next video. Till then, bye-bye.